morning, dear students. Welcome to Purnachandra Higher Secondary School. So, in this class, we are going to move into a new chapter, chapter number 5, because in the previous video lecture we have completed the chapter number 4. Okay. So, in this class, we are entering into a new chapter, that is chapter number 5. Chapter number 5 is your magnetism and matter. Okay. So, first of all, let us first understand what is magnetism. So magnetism is the property of a substance by which it can attract or repel something. That is the property of a specified substance, not all the substances. Okay, so magnetism is a property by which a specific substance will attract or repel some object. Okay, so that's why that property is conjured, occupied by a specific type of materials. Clear? Now let us know about some important few common points about the magnetism. The first very important point is that Earth itself behaves like a magnet. Okay, Earth itself behaves like a magnet having a south pole, magnetic south pole, and having a magnetic north pole. So how could you recognize which one is the magnetic south pole and magnetic north pole? So for this, let us suppose we will take a magnet. Okay, and we will just freely hang it. We will just freely hang it. Okay, and just oscillate it. Then after some time, it will remains as it is and align towards a specific direction. Clear? So the north pole of this magnetic needle or the magnetic substance or the magnet, okay, directed towards the magnetic the south pole of this directed towards the magnetic south pole of the earth, okay, and the north pole of the freely suspended magnet directed towards the north pole of the magnetic north pole of the earth. Okay, so that's why from this we can know which is the magnetic south pole and which direction is the magnetic north pole. Okay, this is one very important point. Another important point is that the object which contain the magnetism property, okay, so they have two certain polarity. Okay, one is north pole, another one the south pole. So if you divide this substance which contains the magnetism, or simply call it a magnet, into so many parts, okay, each part itself behave like a magnet. Each part itself behave like a magnet. Clear? That means suppose this is a magnet. Okay. Suppose this is your north pole, this is your south pole, and I will piece it or divide it in a different pieces. So each piece, look at here, each piece is having a specified north and south. Specified north and south. Clear? Specified north and south. So that's why from this we can easily conclude that magnetic monopole does not exist. As we have known from the electrostatics that in case of a charge, electric charge, a single charge can exist, whether it is a positive charge or whether it is a negative charge. A single charge can exist, but whereas in case of a magnetic or magnetism, okay, there is no existence of monopole. There must be dipole. There must be two polarity. One is north pole, one is south pole. So a single pole does not exist. Understood? So these are the few very important points we have to know about the magnetism. Clear, all of you? Then next we just know about the bar magnets, okay, or the magnets. Let us know about the magnets. Clear? So what are magnets actually? What are magnets? So magnets are the objects, specific objects that contain, okay, or that produce a magnetic field around itself. Clear? So magnet is a substance which produce a magnetic field around itself. So that object is called as magnet. Clear? So generally in our earth, Generally, in our Earth, we have two types of magnets available. The first one is your natural magnets. Number two is your artificial magnet. Okay, so first one is your natural magnets. Number two is your artificial magnets. Clear? So let us discuss few points about the natural magnets. So what do you mean by natural magnets? Now natural magnets occur in nature, in the earth core. Clear? They occur in nature. So that's why it is called a natural magnet. That is a very important point. So natural magnets are available naturally. We can got it naturally. Okay, and another very important point is that the natural magnets is having weak magnetism, or it produces a weak magnetic field. Clear? A natural magnet produces a weak magnetic field. So examples of your natural magnets is your lodestone. This is an example of lodestones are the examples of the natural magnets which available naturally. Clear? Okay. So now come to the artificial magnets. So as the name indicates, artificial. So that's why it is a man-made magnet. It will not available naturally. It is man-made. So that's why the artificial magnets we can get in different shapes. Very simple. Okay, and the magnetism is also very more. So that's why the magnetic field produced by the artificial magnet is more. Here all of you, whereas the magnetic field produced by the natural magnets is very weak. So it is having strong magnetic field. Artificial magnets is having strong magnetic field. Okay, whereas the natural magnets is having weak magnetic field. Understood all of you? Okay, so this is some of the important or the types of magnets available. Okay, so next another important Euro point, or you can tell, that is a bar magnet. Clear? Okay, so what do you mean by bar magnet? So bar magnets includes under the artificial magnets. First of all, remember, because just I told you that the artificial magnets are available in different shapes. So that's why when the artificial magnet shaped as a bar, a rectangular bar, okay, then that type of magnet is called your bar magnet. Clear all of you? Okay, so when the artificial magnet is shaped into a shape of bar, then that type of magnet is called your artificial magnets or bar magnets. So this is an example of your bar magnets, which is having two poles. One is north pole, another one is your south. Clear all of you? Clear all of you? So bar magnets is a shape of rectangular bar. That's why it is called bar magnet. It is included under the artificial magnets. Number two, number three, it is having strong magnetic field. Okay, it is having strong magnetic field. Okay, so now let us discuss some properties about the bar magnet. Okay, let us. What are the different important properties of your bar magnets? What are the important? The first important properties is that the bar magnet. Listen very carefully. The bar magnet is having two poles. One is north pole, another one is your south pole. It has two poles. One is north pole, another one is your south pole. Understood? Okay. And another very important point is that the strength, okay, or the magnetism is more nearer to the pole. This is the nearer region, nearer to the pole. Okay. So in these regions, the magnetic field or strength of the magnetic field is more. So that's why the strength of the magnetic field is more at the poles. Just at the poles, not in the middle region. But in the middle region, it is somehow a little bit weaker than the pole region. Understood all of you? This is the number two property. The number three property. What is the number three property? That if this bar magnet is suspended freely, if we will suspend the bar magnet freely, understood? Then we can get the magnetic north pole and the magnetic south pole. How? because when this bar magnet is suspended freely just like that, then the north pole of the magnet, look at here in the figure, the north pole of the magnet is directed toward the magnetic north pole of the earth, and the south pole of the magnet directed towards the south pole of the earth, magnetic south pole of the earth. Clear? Understood all of you? Okay, so this is another property. Then another property is that it will divide this bar magnet into 2 halves or 3 halves or 4 halves. Okay, still the polarity does not change. Okay, because it is having, still it is having 2 poles. One is north pole, another one is your south pole. Because monopole does not exist, just like discussed. How many parts you will divide this one? You will get how many poles? 2 poles. So single pole of magnet does not exist. Understood all of you? Another very important point is that if we place 2 bar magnets, listen very carefully, if we place 2 bar magnets nearby to each other, then the equalike poles, that means the similar poles, repel each other. Okay? And the unlike poles, that is the dissimilar poles, attract each other. The north pole and north pole, or south pole and south pole, repel each other, whereas the north pole and south pole attract each other. Clear all of you? Okay? So these are the some of the important properties of your bar magnet. Clear all of you? Okay? Now another important point let us discuss from this bar magnet. That suppose I am taking a piece of paper, I will place a bar magnet on it or below it, suppose below it. Okay, I am taking a piece of paper, I will place a bar magnet below it and I will sprinkle some dust. What type of dust? Iron dust on the paper. Then what I can feel or what I can observe, look at this figure very carefully. So I can observe that these type of patterns I will get on the paper. These type of patterns of what? These type of patterns of your the sprinkled irons. Okay, so these type of patterns I will get on the paper when I will place a bar magnet below the paper and sprinkling some iron dust on it. These type of patterns I will get. Okay, and what I can feel, these lines are emerging out from the north pole and going into the south. Clear? These are the lines we can get, or we will get when I am sprinkling some iron dust on the paper. Clear? So these lines, remember, these lines are the imaginary lines. These lines are called magnetic field lines. What are these called? These are called magnetic field lines. Okay, so I can define the magnetic field lines. How we can define? Now magnetic field lines are the imaginary lines which are drawn along the direction of your magnetic field. Okay, so magnetic field lines are the imaginary lines which can draw along the magnetic field. So that means in other words I can say the magnetic field line shows the direction of the magnetic field. Understood all of you? Clear? And remember one point, these are imaginary lines. These are not real lines, these are imaginary lines. These helpful to show the direction of the magnetic field. Okay? And number 2, it is always emerging out from the north pole and you are emerging into the south pole, outside the magnet, and inside the magnet they will move from south pole to north pole. Clear? So that's why now I can discuss the properties of your magnetic field. Okay, so magnetic field lines. So suppose let us discuss the properties of your magnetic field lines. Okay, so what are the properties? The first property, the number 1 property, the first property of your magnetic field lines, that the magnetic field lines are always generating from the north pole of the magnet, okay, and entering into the south pole of the magnet outside the magnet, and inside the magnet it will moving from south pole to north pole. That's why the magnetic field lines form a closed loop. Okay, the magnetic field lines form a closed loop. Look at here. The magnetic field lines are generating from here. Outside the magnet, it will again move. So they are forming a closed loop. Understood? So this is the first property. The magnetic field lines forms a closed loop. Number one. Number two property. So very carefully. The magnetic field lines. Okay, the magnetic field lines. The number of magnetic field lines in a given region gives me the strength of the magnetic field in that region. Again, I will repeat. The number of magnetic field lines at a particular region gives me, gives me the strength of the magnetic field at that region. So, if the number of magnetic field lines increases, the strength of the magnetic field increases. Clear? This is the number 2 property. Okay. Then what is the number 3 property? The number 3 property is that no two magnetic field lines will intersect with each other. Look at here. So suppose this is a magnetic field line, this is a magnetic field line. If they will intersect, suppose I assume that this is a magnetic field line and this is a magnetic field line. Suppose they intersect at point P. Then what happens? Now at point P, this is the direction of your magnetic field of the first magnetic field lines, and this is the direction of magnetic field of the second magnetic field lines. Understood all of you? But unfortunately this is not possible. This is not possible because at a given point we cannot get, listen very carefully, at a given point we cannot get two different directions of magnetic field. That's why this is the reason behind it, that the magnetic field lines cannot intersect with each other. So this is not possible. This is not possible. It's a very important question, that why do magnetic field lines do not intersect with each other. Clear? Okay. Now this is the number 3. Then come to the number 4 property. So what is the number 4 property? Now, if in the magnetic field lines at any point if I draw a tangent, suppose here I will draw a tangent, suppose here I will draw a tangent, suppose here I will draw a tangent, at any point if I draw a tangent, then at that point I will get the direction of magnetic field. The tangent gives me the direction of the magnetic field at that point. Understood all of you? Clear? So this is my 4th property of your magnetic field line. The magnetic field lines and their properties are very, very important. Clear all of you? Okay. So these are the properties of your magnetic field lines. So magnetic field lines, remember, are imaginary lines. Okay, which shows the direction of your path. Which path? Magnetic field. The direction of your magnetic field. And these are the properties just I have discussed. Okay, so the important point is the magnetic field lines emerges from the north pole, going toward the south pole outside the magnet. Inside the magnet, they will move from south pole to north. That's why the magnetic field line forms a closed loop. Clear? Okay. So now this is your discussion about the magnetic field lines and their properties. In this part, another important point is that in this bar magnet, what do you mean by pole strength? What do you mean by pole strength? This is a very important, small but very important part. Small pole strength. Pole strength is nothing but the strength of magnetic pole. Listen very carefully. Pole strength is nothing but the strength of the magnetic pole, so that it can attract an object. That is the pole strength. So pole strength is nothing but the strength of the magnetic pole, so that it will attract the magnetic substance towards it, or attract magnetic materials towards it. That is called your pole strength. Understood? Clear all of you? Okay. So now, because pole strength is denoted as pole strength, because every bar magnet is having a particular pole strength, because there are 2 poles. So there are the 2 poles having different pole strength, very simple. Understood? Okay. So the strength of each pole, Okay, by which you can attract the magnetic material. That is called the pole strength of that pole. Understood? And it is denoted as P. Clear, all of you? Okay. So the unit of pole. Remember, the unit of pole is Newton per Tesla. It is denoted as Newton per Tesla. Newton per Tesla. The T stands for Tesla. Okay, clear? And what is the formula? This is the unit. This is my unit, SI unit of your pole strength, the Newton per Tesla. But what is the formula for pole strength? The pole strength is equal to W divided by I. This is the very universal formula because the pole strength is equal to W means work done. Listen very carefully. W means work done in moving a magnet through a wire. If suppose I will take a wire and I will move the magnet through it, due to this motion a current is generated. So that current gives me the pole strength of that magnet. Clear? So pole strength is nothing but the work done divided by current. Work done W divided by current I. Okay. W is the work done in moving the magnet along the wire. Along a wire, okay, and I is the current flowing through the wire. Clear? So this is my pole strength. Understood? Okay. So these are the introductory class of your magnetism and matter. Clear? These are the introductory class. In this class, let us summarize what we have discussed. Now we have discussed what is magnetism, the important things or what are the important things, the important properties of magnetism. Okay, then we move into the magnet, natural magnet, artificial magnets. Okay, then we move into the bar magnet, the properties of your bar magnet. Next, we discussed about the magnetic field lines, the properties of your magnetic field lines. Okay, and next or finally we discuss about the pole strength P. Pole strength is nothing but the strength of the pole. The strength of the magnetic pole, okay, by which it can attract a magnetic substance towards it. Clear? Okay, so the pole strength, the unit is Newton per Tesla. The formula P is equal to work done divided by current. Remember this formula to find out the pole strength. Understood? Okay. Okay. So now this is another thing. Let us discuss the last thing. Let us discuss look at very carefully. This is okay. That is how in this part next we will discuss how a magnetic current carrying loop, how it behaves like a magnetic dipole. So let us look at it very carefully. Suppose this is a current carrying loop. Okay, this is a loop in which the current flows in anti-clockwise direction. So if you look from the upward, then if you apply the right hand thumb rule, then I can get the direction of the magnetic field very simply. This thing we have discussed because this is a loop, current carrying loop, which conducts a current I. Okay, which conducts a current I. Okay, so now if you will look this loop from upward, then you will find that the magnetic field is emerging out. Okay, this is the direction of your magnetic field. Look at, so this is the direction of your magnetic field. At the center it is approximately in a straight line, but if you look at these hands, then you will get this type of magnetic field. Look at it. You will get this type of magnetic fields. That is, they are emerging out at upper face and emerging into the lower face. Similarly at this end also. Understood? Okay. So this is actually the direction of magnetic field. These are the loops. So the direction of your magnetic field. Understood? So that means at upper end, when I look at from upward, from the upper end I just feel that the magnetic fields or field lines are emerging out and from the lower emerging in. So that means if or this loop will behave like just like this, or this is a bar magnet, behaves like a bar magnet. Very simple, because we know that in case of bar magnet, if this is your north pole and if this is your south pole, then from this the magnetic field lines are emerging out from the north pole, and this is emerging in, this is the emerging out from the north pole, this is the emerging in. Understood? Okay, so that means when a current carrying loop in which the current flows in anti-clockwise direction, okay, then it behaves like a bar magnet. Its upper part behaves like a north pole, its lower portion behaves like a south pole. Very simple. Understood? Clear all of you? Okay, then in this case, okay, so this magnetic bar magnet is having a particular magnetic dipole moment. Clear? So what is the value of magnet? So that means if I will draw a separate, so this is a magnetic loop, then very simply this is the direction of the magnetic field, okay, and also the direction of your magnetic dipole moment M from magnetic dipole, because we know that the magnetic dipole moment M direction is from south pole to north pole, because magnetic dipole moment is the direction is inside the magnet, so that's why south pole to north pole. So magnetic dipole moment is equal to the current I into the area of the loop. So I into A. Very simple. So magnetic dipole moment, the formula is I into A. The direction is from south pole to north pole. So look at the figure. Very simple. So this is the direction of your magnetic moment. So that's why a current carrying loop behaves like a bar magnet. Very simple. Clear? And the magnetic moment formula is, or magnetic moment is equal to, magnetic dipole moment is equal to M is equal to I into A. This formula is applicable when the loop is having one turn. If the loop is having n number of turns, okay, then M I can write n I n. Very simple. Okay, just n I will multiply if n is equal to number of turns. Clear all of you? Okay, so from this we can easily visualize that any current carrying loop behaves like a bar magnet, having a specific north pole, having a specific south pole, and having a specific magnetic dipole moment whose value n is equal to n. N is the number of turns, I is the current flowing through the loop, A is the area of the loop, and the direction of the magnetic dipole moment is from south pole to north pole. Okay, so for this class we have discussed this much. Next class we are moving to your magnetism matter part 2. Clear? Have a good day. Thank you so much.